Fuel drawn from the tank flows to the OEM-supplied pre-filter. This filter is a minimum 10-micron filter with a water and fuel sensor. Fuel leaves the pre-filter and flows to the inlet of the ECM cooling plate. The lift pump is controlled by the ECM and runs for approximately 30 seconds whenever the key switch is turned to the run or start position. The output from the electric lift pump ensures that the gear pump is primed so the engine can start quickly. A check valve incorporated into the outlet fitting of the ECM cooling plate ensures that the lift pump output goes to the gear pump and not through the ECM cooling plate. When the gear pump speed reaches sufficient levels, it pulls fuel directly through the ECM cooling plate and the open check valve that is installed in parallel with the electric lift pump. Fuel enters the gear pump, where it is pressurized to a minimum of 10 psi at cranking speed and 70 psi with the engine under load. Before the fuel leaves the gear pump, it passes a pressure regulator valve. When fuel pressure is above 175 psi, it acts against spring tension to open the valve. The fuel is returned to the inlet side of the gear pump. The output from the gear pump flows to the pressure side fuel filter. This filter has a 2-micron rating. Fuel from the filter returns to the actuator housing. An air bleed orifice in the housing allows a small amount of fuel to flow to the drain. Any air in the fuel is pushed through this orifice and prevented from entering the high-pressure pump. The fuel pump actuator receives a pulse-width modulated signal from the ECM. This fuel pump actuator controls the amount of fuel metered into the high-pressure pumping chambers. Controlling the fuel flow into the high-pressure pump prevents pressurizing more fuel than is needed. This actuator is a normally open valve. Current is increased to reduce flow to the pump, thus lowering fuel rail pressure. In the high-pressure pump, the fuel is pressurized by the 2 cam-driven barrel and plunger assemblies. These assemblies create the high pressures needed for injection. Inlet and outlet check valves act to develop and hold fuel rail pressure. The inlet check valve holds fuel inside the pumping chamber so that it may be pressurized. The outlet check valve holds the fuel rail pressure inside the rail so that it does not leak back into the pumping chamber. A failure of a single pumping chamber results in a pressure imbalance and possibly low rail pressure. The ECM can detect this condition and will register a fault code. Fuel that leaks past the barrel and plunger is collected in a drilling in the pump head and routed to the air bleed circuit for return to the fuel tank. The pressurized fuel leaves the high-pressure pump and flows through piping to the fuel rail. This rail and the high-pressure fuel line serve as an accumulator, storing the fuel under pressure until it is needed for injection. Because the actuator is a normally open valve, any circuit problem, such as an inadvertently disconnected actuator wire, will cause the actuator to open. This results in maximum flow to the high-pressure pump, leading to opening of the fuel rail pressure relief valve. This valve protects the rail, lines, and injectors from any malfunction causing overpressurization. When the fuel in the rail exceeds the valve setting, the valve opens and fuel is returned to drain. The fuel rail pressure relief valve is a two-stage valve. When closed, only a small area is exposed to the fuel in the rail. This makes the valve a fast-acting valve that opens at approximately 1800 bar. Once opened, the outer plunger moves to its stop, and a larger area is exposed to the high-pressure fuel. This causes the inner plunger to open, and rail pressure drops to 1000 bar. After the fuel rail pressure relief valve opens, the rail pressure must approach zero to reseat, close the valve. The fuel rail is connected to each of the injectors by a fuel line and a high-pressure connector. Edge filters in the high-pressure connectors trap large particle debris. If an injector is replaced, a new high-pressure connector must be installed. At the injector, fuel flows through the supply inlet passage, pressurizing the injector nozzle and the control chamber above the injector plunger. Injection begins when the ECM energizes the coil and allows the valve ball to lift off of its seat. This allows fuel to flow out of the control chamber to drain, reducing the pressure in the chamber. The reduced pressure above the control plunger allows the needle to lift off of its seat and high-pressure fuel to flow into the cylinder through the nozzle. Since the drain passage is slightly larger than the supply passage, the fuel pressure above the control plunger does not build as long as the valve ball is off its seat. To end injection, the ECM de-energizes the coil, which seats the valve ball. The pressure above the control plunger and the force of the spring causes the needle to seat in the nozzle and end injection. Fuel flowing out the fuel return from the injector flows back to the fuel drain block. The drain line check valve is installed in the fitting in the cylinder head. This check valve maintains 0.7 bar back pressure on the injectors. The drain lines route drain fuel from the injectors, fuel rail, and fuel pump to the fuel drain block. From the drain block, a drain line allows the drain fuel to return to the fuel tank. The restriction of the pressure side fuel filter is checked using the fitting on the fuel filter mounting head. Record the pressure at the filter inlet, front fitting, and then at the filter outlet, rear fitting. If the difference between the two readings exceeds specification, the filter must be replaced. The output of the lift pump can be checked using a pressure gauge at the inlet to the gear pump. A test port is located on the back of the gear pump for this purpose. Turn the key switch on and record the lift pump pressure. If the lift pump pressure is low while the lift pump runs, make sure the system is primed and the check valve at the ECM cooling plate is not blocked open before replacing the lift pump. To test the low-pressure fuel system restriction, install 0 to 30 mm mercury vacuum gauges at the gear pump inlet and at the OEM connection manifold prior to the ECM cooling plate. Install a .043-inch orifice diagnostic tool at the pressure filter head to simulate fuel flow at rated engine speed. Run the engine at high idle and record the gauge readings. Should it be necessary to replace the lift pump, begin by disconnecting the battery. Always disconnect the negative terminal first to reduce the risk of arcing. Disconnect the wiring to the lift pump. Thoroughly clean all fittings and components before disassembly. Debris, water, steam, or cleaning solution that enters the fuel system can cause severe damage. Removal of the pressure side fuel filter provides needed access for service. Remove the low-pressure fuel line clasp. Then remove the fuel lines at the lift pump and ECM cooling plate. Remove all ECM electrical connectors and wire harness clips. Remove the ECM and then remove the cooling plate. With the ECM cooling plate removed from the engine, the hardware attaching the lift pump to the cooling plate is easily accessible. Remove the lift pump from the cooling plate. Install the new lift pump to the cooling plate. Torque the fasteners to the specification given in the service literature. Install the fuel lines, taking care of the following items. The ECM cooling plate check valve should be checked for cleanliness and freedom of movement. The check valve assembly is then installed in the lower outlet port. The fuel lift pump tubes are supported while tightening the cooling plate inlet and outlet fittings. Do not allow the tubes to bend. Install the ECM cooling plate and lift pump assembly and the ECM on the engine. Reconnect the fuel lines, low pressure fuel lines, clasp, and wiring. Reinstall the pressure side fuel filter if removed for access. Reconnect the battery. With the connector removed and the key switch on, power supply to the heater must be at least 12 volts. If the voltage does not meet specification, refer to the OEM repair manual. The fuel heater is switched on and off by a bimetallic switch at the filter head. Test the switch with an ohm meter. It should register as open, high resistance, above 18 degrees centigrade, and register as closed, near zero resistance, below 1 degree centigrade. The fuel pump actuator can be tested for open and short circuits using an ohm meter. Resistance from the positive fuel pump actuator pin to ground must be at least 100 k ohms. The resistance from the pin to pin of the actuator should be 1.5 to 5.0 ohms. If the actuator does not meet these conditions, the actuator must be replaced. Remove the cap screws that hold the fuel pump actuator to the actuator housing. And remove the actuator. Inspect the actuator pins for wear or corrosion. Closely inspect the pigtail harness for wire insulation damage. Inspect the plunger through the 3 fuel passage windows. A shiny, scratch-free surface indicates the actuator is acceptable for reuse. Any signs of scuffing, especially when accompanied by intermittent fault codes 449, 2215, or 2216, indicate the need to replace the valve. To install the actuator, lubricate the O-rings with clean engine oil and install the fuel control valve in its housing. Do not use the cap screws to pull the actuator into the housing. Torque the cap screws to specification. Connect the engine wiring harness to the fuel pump actuator. Start the engine and check for leaks. Disconnect the wiring harness from the fuel pump actuator. Disconnect the fuel supply line at the actuator housing. Disconnect the high-pressure fuel line from the actuator housing. Disconnect the fuel drain from the actuator housing. Remove the 3 cap screws that hold the fuel pump actuator housing to the high-pressure fuel pump head. Remove the actuator housing and gasket. Clean the mounting surfaces of the pump head and actuator housing with contact cleaner. Install a new gasket. Note, this gasket should be installed dry. Install the housing on the pump and torque the cap screws to specification. Reconnect the high-pressure fuel line, the low-pressure fuel supply line, and the fuel drain line. Reconnect the wiring harness. Remove the fuel pump actuator housing following the procedure given elsewhere in this training. Remove the high-pressure fitting from the threaded hole in the back of the high-pressure pump head. Note, if it is necessary, use a tapered punch to remove the seal washer. Insert the punch into the center of the seal washer and work the seal out of the bore in the pump head. Inspect the thread and cavity in the pump head for nicks or burrs. Clean the outlet fitting bore with contact cleaner. Install a new seal washer onto the fitting. A small amount of lubriplate will help to keep the seal in position during installation. Torque the fitting in the high-pressure pump head to the torque specified in the service literature. Install the fuel pump actuator housing and reconnect the fuel lines and wiring using the procedure given previously in this training. Operate the engine and check for leaks. When checking the pump high pressure fitting, snap the throttle several times to increase the fuel rail pressure. The high-pressure fuel pump head can also be replaced without removing the pump from the engine. Begin by removing the fuel pump actuator housing. Follow the procedure given previously in this program. Remove the fuel pump drive gear cover and bar the engine over slowly to top dead center. This is where the line on the pump gear aligns with the line on the gear cover. Remove the upper support bracket. Remove 2 of the 4 pump head cap screws. Remove screws located diagonally from one another. Remove the last 2 cap screws by loosening each cap screw 1 turn at a time. Alternating between the 2 cap screws prevents the housing from binding under pressure from the plunger springs. Support the pump head to prevent it from falling as the cap screws are removed. Remove the springs and spring retainers from the barrel retainers. Keep track of the position of these parts so that they can be returned to their original location. If a new pump head is being installed, it will be supplied with new springs and tappet retainers. If the plungers are fully upward in their bore, light air pressure at the inlet fitting may be used to aid in plunger removal. Remove the plungers one at a time and inspect for damage. Scoring or scratches that can be felt are reason to replace the pump head. If the plungers are acceptable for reuse, they should be cleaned with contact cleaner. The plungers must be returned to their original barrel in the original orientation. If necessary, mark the bottom of the plunger with a felt tip marker to aid in maintaining correct orientation. Return the plungers to their original locations. Install the springs and spring retainers on the barrel retainers from which they were removed. While the fuel pump head is removed, inspect the cam housing, tappets, and tappet bores. Use an O-ring pick to remove the tappets from their bores. Inspect the camshaft for wear. Measure the tappet guide groove and compare the measurement to the specification in the T&R manual. Visually inspect the tappet guide pins and replace the fuel pump if the pins exhibit more than 25% wear. Reinstall the tappets into the tappet bores from which they were removed. Then install new O-rings on the cam housing. Draw the pump head down by alternately tightening 2 of the pump head bolts that are diagonal from each other until the head just touches the cam housing. Install the remaining 2 pump head bolts. Torque the pump head bolts to the specification listed in the service literature. Connect the upper support bracket to the high-pressure pump head in the following order. Connect the bracket to the pump head, installing the bolts finger tight. Connect the upper support bracket to the cylinder head and torque the bolts to specification. Torque the bolts holding the support bracket to the high-pressure pump head. Reinstall the fuel pump actuator housing, fuel lines, and wiring using the procedures given previously in this training. Reinstall the fuel pump drive gear cover. Priming a system that has been run out of fuel or has new filters installed may require several lift pump cycles. It is recommended that the OEM-mounted 10-micron suction side filter be installed full of clean diesel fuel and the engine-mounted 2-micron filter be installed empty. It is also important that the 10-micron filter have a standpipe. If the 10-micron filter has a standpipe, the fuel lift pump should be able to fill a dry pressure side system within 3 or 4 lift pump cycles. If the warning lamp lights as a result of water present in the suction side filter, the pressure side filter should be replaced. This is due to the fact that the pressure side filter has some water stripping capabilities, but no provisions for draining.